Oops. Okay. Good morning. Welcome back. Let's just talk about a few things here where we're at. Not everyone has completed the test yet, but when everybody does, you guys will be able to see which ones got right and which ones got wrong. But overall, the test grades were pretty darn good. The majority of the class either has an A or a B on that test. So overall, I thought it went pretty well. So where are we going now? We are on Friday, September 20th. If you look at the schedule, first of all, that whole first chapter, we called it, it was chapter 2 from the algebra book. Remember, we're kind of using 2 textbooks in here. We're done with that algebra book, okay? The rest of the time, we're now starting on chapter 1. I know it feels backwards. It feels like we just did chapter 2. We're on chapter 1 of the pre-calculus book, and we're going to be using that pre-calculus book the rest of the way, okay? So what did we do for those first couple weeks? We were basically just solving equations, and then a little bit of application problems where you had to set up your own equations and whatnot and solve. But the majority of it was solving equations. Now we're going to get into more of the pre-calc stuff, and basically from here on out, we are going to be focusing on functions, function notation, function behavior, different kinds of functions, linear functions, quadratic functions, exponential functions, logarithmic functions, blah, blah, blah. And then at the end of the semester, we'll have some focus on trigonometric functions, trigonometry. Okay? So, section 1.1, functions and function notation. I've put a few documents on Blackboard. We're going to do some Desmos activities today to kind of get you thinking about conceptually what a function is. But the first thing I want to do is have a little bit of an introduction to functions. And this is going to be super review for some of you. But let's go back to 9th grade a little bit here, and let's review some terminology, some vocabulary. Oops. And then we'll do some activities that go along with it. Okay, so here we go. Functions. What are they? Some of you might know what they are. Some of you might know a formal definition. Some of you might have an idea of what it is, but you're not 100% sure. I'm going to show you a mathematical definition that'll come right out of like a math book, or if you Google it or something like that. Here's a mathematical definition. A function is a relation that matches each element of a first set to an element of the second set in such a way that no element of the first set is assigned to 2 different elements in the second set. Yeah. Right? Like that's a lot. Like what's going on there, right? So it's a relation, some type of relationship. We have one set over here, some set of numbers, mostly numbers, and we have some other set over here, some set of numbers, and somehow those 2 sets are related to each other. So it's a relation. Here's the key part. In such a way that no element in the first set is assigned to 2 different elements in the second set. That's kind of the key. That's what makes a function a special type of relation. So we're going to talk about what that means. And this really turns students' brains around a little bit. So I'm going to try to conceptualize it for you a little bit. So first, before we even talk numbers, let's talk something that's non-numbers. Okay, you got 10 seconds. What's your favorite movie? Think of it. I'll give you a little moment to think. Everybody got their favorite movie? Okay, here's what we're going to do. We're going to create a function, and that function is going to take the movie as the input of the function. And then the rule, a function is a rule. It's the rule that relates the first set to the second set or relates the input to the output. The rule is going to be to take the first letter of the title of the movie. And then the output is going to be that letter. So we have an input, which is the movie, and we have an output, which is the first letter of the movie. So you've probably seen like a function machine picture that looks like this, and I'll be drawing up this type of diagram like many, many times from here on out. We have a set, and that set contains a bunch of elements. So that first set, what's going to be in there? Movies. My favorite movie, your favorite movie, your favorite movie, your favorite movie, and so forth. Okay? We take somebody's movie. We put it into the function. What did we say the function was going to do to the movie? Take the first letter of the movie and spit it out as an output. Okay? I'll go first. My favorite movie. Anybody want to guess what my favorite movie is? What was that? Super what? Superhero? No. Good thought, but that's my favorite movie. Back to the Future. Anybody? Fantastic. All three of them. Okay, so if my favorite movie goes in, that's the input. What's the output? B. Is there any other possible output that could have resulted from that? No. Back to the Future only starts with B. It doesn't start with anything else. Do you guys agree? Okay. I have a couple examples. Here's another favorite movie of mine. Mission Impossible. Ethan Hunt's kind of like a superhero. Like he should have died 1,000,000 times and he never did. Yeah? What would it produce? M. Is there any other letter that Mission Impossible possibly could have started with? No. It starts with an M and that's it. End of argument. Right? Okay. Here's another one of my favorite movies. Billy Madison. Okay. What would Billy Madison produce? B. But hold on. Look at our output. B is already there. So do we need to write him again? No. He's already there. B is already there. Now, did I break my rule where I said every element of the first set can only be mapped to one element of the second set? Did I break that rule? No. But this is where students get turned around. Sometimes they're like, oh, 2 different inputs produce the same output. That must not be a function. Wrong. It still is a function. I can have 2 different inputs that produce the same output. What can't I have? I can't have one input that produces 2 different outputs. Billy Madison only starts with 1 letter. There's no second letter that Billy Madison starts with. So Billy Madison only produces B, nothing else. Right? Okay, anybody want to share their favorite movie? Aristocats starts with a A. So Aristocats would produce A. Anybody else? Sweet Home Alabama starts with a S. Okay, good enough, right? You guys get it, right? So I defined that function. I just made it up. I said, let's do the first letter. So let's try a few other things. Here's a question for you. How many elements, we call them elements, sets have elements in them. How many elements would there be in that set? Right now there's only 3. Could I add more? How many more? Almost unlimited. Is there an infinite number of movies? How many movies are there? A lot. Is it infinity? Pretty close. But infinity is just this concept that never ends. And we do know that if it was humanly possible to count every single movie, eventually we would get to the end of the list, right? It does not go on forever. So there would be many, many, many movies that could be in this set. Right? Okay. How many elements could we produce in this set?
It's dependent on the
Let's say we have millions and billions and trillions of movies. Let's say we took every movie that ever existed and we put it in here. 26, I heard. Who came up with that? Why would it be 26? There's 26 letters in the alphabet. So yeah, I would agree that there would probably be 26 in here, but we'd have to make some stipulations on this, right? The stipulation would be that all the movies have a title that uses the English alphabet, right? Yeah, what is it? Just reading my brain here. What happens if I tried this one? Another one of my favorite movies. What am I going to do with that? Another one would be 8 Mile. You guys ever seen 8 Mile? What's his name? Eminem. Yeah.
I was like, do you want like his first name?
Yeah. This would kind of break my machine, wouldn't it? Because I defined it to be taking the first letter of the name of the movie. So now this one starts with a number. So now I'm like, now I got to redefine my rule somehow. Or maybe I just say, the only guys I'm going to count are the guys that start with a letter. So ones that start with a number don't count. That would be me defining my domain, right? So there's different rules that we'd have to think about. Okay, so let's talk vocabulary here. We have 2 sets, and then we have a function, right? The first set goes into the function, spits it out. Okay, we often call the items in this set the inputs of the function. It goes in, right? There's a mathematical term for the set of all inputs, and I just used it a few seconds ago. What's the word? The domain. Very good. The domain is the set of all inputs that go into our function, okay? We call the input values, or the members of the domain, we refer to those as the independent variable. Like you guys were independent when I said, what's your favorite movie? Nobody forced a movie on you, right? You got to independently choose whichever movie you wanted, right? That's why we call it the independent variable. Now, when we graph it mathematically, what letter do we typically assign to the input? X. Typically X, right? Okay, so I got 4 bullets there. There's 4 corresponding bullets that go in here, and I bet you can already figure out what they are. Instead of input, output. Instead of domain, range. Very good, domain and range. The range is the set of all outputs. Instead of the independent variable, dependent. Think about that. I independently got to choose Back to the Future. I chose it. Did the B, was it independent or did it depend on something else? It was dependent. It depended on the name of the movie. He had no choice but to be a B, right? So the independent versus dependent thing, okay? And instead of X, we use Y. Or when we use function notation, we often use f of x, or g of x, or h of x. That's function notation, right? Okay, so this is a review. You guys have seen this before, but this is when I drop the word domain and range, independent, dependent. That should resonate with you. Okay, so how do we represent a function? As far as I'm concerned, there's 4 ways to do it. We can verbally just speak words or write a sentence, okay, and give a representation of a function. We can do it numerically by making a table, like a table of x's and a table of y's, like a chart. We can graph it and just give the picture of a graph. That's a visual representation. Or we can give an algebraic formula, an equation, right? So here's 4 ways to represent the exact same function. First, let's read the verbal description. The verbal description says, y is a function of x such that all y values are 3 more than twice each x value, where x can be any real number. The part at the end, where x can be any real number, that's defining the domain. I'm saying from negative infinity to positive infinity. It can be any number we want. So I put that value in. The rule is to take it twice the value of x, double it, and after we double it, add 3. That's the rule. So if I gave you 10, you would double it into 20 and you would add 3. 10 goes in, 23 comes out. Right? Okay. So what happens then? Let's jump down to this one. Could you come up with an algebraic formula that matches that? And what would it be? Three more than twice each x. 3 more than twice each x. 3 plus 2x, or 2x plus 3. Yeah, good. You agree? Y equals 2x plus 3. We double it and we add 3. Okay? How about the visual, the graph? Now I already flashed the answer up there, but had I not done that, could you have identified the formula? It's just a line, right? Y equals mx plus b. What's the y-intercept? 3. What's the slope? Just count up 2 over 1, 2. Y equals 2x plus 3. Okay, what happens? I don't think I have this in the PowerPoint. Let me put up a pen. I could fill in this chart, right? Like I already said one of them. I think I said 10, right? 10. If 10 went in, what would come out? 23. If 6 went in, what would come out? 15, and so forth. And I could just keep going. That chart would go on forever, right? I could independently choose any input value that I want. That'd be the first column, the x column. And then the second column, the output, that's not independent anymore. Now that depends on the formula. That's a calculated value, right? Okay, so let's just practice a few is it a function or not exercises here. Here's a list of ordered pairs. These are x comma y, so 1 comma 2, that's a point, an ordered pair. 2 comma 3, that's a point. So what that's saying is 1 produces 2, 2 produces 3, 3 produces 4, 4 produces 5, 5 produces 6. Yes or no? Is that a function? Yes. You guys agree? Definitely a function. This PowerPoint's on Blackboard too, so if you guys want to review this, you can always do that. Okay, how about the second one? 1 produces 3, 1 produces 5, 0, 4, 2, 2, 2, 6. Is it a function? No. Why not, Isaac?
There's more than one producing different output.
Right. How could 1 go into a function and produce 3, but then it also produces 5? Remember our rule was each element of the input or the domain can only produce one member of the range. This would be like saying there was a movie that started with 2 different first letters. Impossible. Not a function. Right? Not a function. How about the third one? No, why not? Yeah, the 2 produces a 5 and the 2 produces a 7. Again, 2 can't produce 2 different outputs. Not a function. Not a function. And how about the last one? Yeah, we're good there, right? Let's try this one. Does that look like a function? Yes, it is. Let me change it now. How about that guy? No, definitely not, because now 1 is somehow producing both 2 and 4. Not a function, right? So I've been giving you ordered pairs. That one, that was like doing a table. How about a graph? How about the graph on the left? Is that a function? How about the graph on the right? No. See the difference? The graph on the left definitely is, and the graph on the right is not. So the question is, without even thinking too hard, down here it says, graphically speaking, how can you tell? Be more specific.
Like there's 2 points that have x as the independent.
Right. Yeah, there's 2 points. Like on this one, if you choose any x value, all the way from infinity all the way to negative infinity, any x value, and then you go up or down to find his corresponding y on the graph, there's only going to be one spot that it hits, right? But let's say on this one I choose an x value, say right here. Which y value goes with that x value? Well, there's one right there, but there's also one right there. So there's a test for this. What do we call it? You guys know that one? It's called the vertical line test. If you draw a vertical line, it's called the vertical line test. If you draw a vertical line through any graph, if it only cuts the graph one time, then you're good to go, right? So look at this first guy, and imagine drawing a ton of vertical lines through it. Are any of those vertical lines ever going to cross the graph twice, or 3 or 4 or 5 times? No. So what do we know about that top left guy? It's a function. What about this guy? Definitely not. Can you visualize a vertical line that would break our rule here? Yeah, I could cut it. Actually, it would go through it 3 times right there, right? How about the one on the bottom left? Definitely not. How about the one on the bottom right? The one on the bottom right is good, right? So 2 of them are functions, 2 of them are not functions. They're still a relation. I mean, it's not like they're just totally made up. They're just not a function, okay? They're not a function. Okay, here we go. First one, x plus 3, is that a function? Absolutely. X squared minus 4, is that a function? No? Why not? Is there any value of x? We said the first one was a function, right? Is there any value of x that's going to produce more than one output? Can you think of one that's going to break it?
No, it's good.
It's good. Yep. Doesn't matter. Were any of you thrown off by this? 2 produces 0, but so does negative 2. Is that okay? Sure it is. That's like Back to the Future and Billy Madison. They both produce B. We're good. Right? So we're good. How about the last one? No. Because if I put in 4, and I'm saying plus or minus the square root of 4, that'd be plus or minus the square root of 4, which is 2. I'm saying 4 produces 2, and it produces negative 2. Can't do that. That's not a function. Not a function. Okay. Hopefully that helped you a little bit with your terminology. What I'd like you to do, we have 2 Desmos, and I don't think we'll finish both today. We might. Go to section 1.1. I'm on Blackboard. Go to course docs and links. You guys see section 1.1? That was the PowerPoint we just looked at. I want you to click on Function Carnival, the top one. There's part 1 and part 2. Click on the top one. Now the top one is a little bit different format than the ones that we've done. We've done the Desmos in here or no? Yeah. Help me out. I get you guys screwed up with my other class. Have we done 0 Desmos activities in here? Oh my gosh, this is brand new for you guys. Okay. Let me tell you what Desmos is. Click on that top link. Sorry, I'm getting you guys mixed up with my other class. The top link will bring you to right here. Okay. What you want to do when you join, I'm going to have you do probably 7, 8, 9, 10 of these throughout the semester. Okay? What you want to do when you join is you want to create yourself a free account. And the reason I want you to create a free account is because you might start on an activity and then you might have to go somewhere and leave it and come back and do it later. And I don't want you to have to start all over from scratch. You can sign in and you can pick up where you left off. Does that make sense? So when you click join, I think it will prompt you to create a username and a password. Does it? Go ahead and do that now. And then every time, you can tell your computer to save it so that you don't have to log in every single time. And then I'll show you what it looks like on my end. The teacher end gets a little bit different view. I'm going to sign in. I'm going to go to history, and we are on Function Carnival 1. It looks like 6 of you are already in. So you got to type your name so I can see who you are. Okay, 1, 2, how many people are here today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 1 of you who's not in yet. There you are, Harmony. Okay, all 10 of you are in. So this is what I see. I can see who's in here. This is my teacher dashboard. So what do we want to do here? We just want to go through. I got to look at a student screen really quick and see what your guys' looks like. Okay. We want to, it's just a kind of do-it-yourself activity, right? It says draw a graph of Cannon Man's height versus time. So time is our independent variable. Height is the man's dependent variable. So they want you to construct a graph. Okay, there's a couple ways to do this. On your tool, notice there's a pencil where you can just draw. There's also a dot where maybe you want to plot like a dot and a second dot and a third dot and a fourth dot if you want to do that. There's also a straight line tool if you just want to connect 2 dots. And then there's the eraser. Do you guys see the four things there? So what I'd like you to do is see if you can draw a graph. I see a few of you. You see how I can see all your guys' graphs here? A few of you are already doing it. Try to graph his height versus time. So if we're using function notation, we're saying Cannon Man's height is a function of time. his height, the dependent variable, is a function of time, which is the independent variable. Or another way to say that, his height depends on the time. So I want to use appropriate language here. Some of you are plotting points, which is probably a smart idea. Because once you plot some points, then you can just play connect the dots, right? So plotting points, like I'm looking at Isaac's right now, very clever idea. He's plotting points, and then he's probably going to connect those points when he's done. By the way, I just give you guys kind of participation points in the gradebook for doing these. So it's not like there's a lot of right or wrong answers. It's more of just an exploratory, conceptually try to feel it out. But every once in a while, I'll give you one of these and I'll say, hey, I need you to finish this and it's worth 5 points. Well, if you finish half of it, I'm not giving you 5 out of 5. You actually got to do it, okay? And every once in a while, there will be certain things that are, accurate or not accurate. So I'm going to give you a grade based on that. So most of you are getting close. Go ahead and try to finish up in the next minute or two on can and man if you can. I like how my teacher screen says, really precise students, 0 out of 10. But a lot of you aren't done yet, though, okay? Apparently it has a threshold for how close you have to be in order to be considered precise. But I want you to think about, Cannon Man didn't just go up and down at the same speed. His speed kind of changed in there a little bit, didn't it? So you really got to try to, standard number 6 up on my board, attend to precision. Be as precise as you can. See, some of you are starting to be similar, taking shape here. Some of you might have found that if you move Canon Man and kind of pause the video, you can, it helped you plot your points a little bit. For the most part, I think we're looking okay. Hey, 2 out of 10 are really precise according to my computer. Should I see who they are? Grace and Madison. All right. Nice job. You guys can move on to step 2. Even if you're not super precise, in the interest of time, try to finish up because we got more to do. I gotta see what your guys' step 2 looks like. Does it give you a graph? Yeah, okay. So in step 2, you're critiquing this guy's graph. Like what's good and bad about it, or what could you do to help him out? So then step 3 is going to be similar, but instead of can and man, you get bumper cars. And then step 5 is going to be similar, but you get a Ferris wheel. So go ahead and go all the way through. If you look up at my screen really quick, Maddie, I'm going to use yours because I thought yours was the best. Do you see Maddie's? The dark blue there? Watch what happens when I click on Show Exact Answer. See the green one? You might not even see it because it's right on top of Maddie's, right? So this is getting a little heavier now, but what shape is this guy before the parachute came out? It's a parabola, which makes what kind of equation? You guys know that one? We're going to get there later. It's a quadratic. Quadratic equations make parabolas, right? And the reason it's quadratic, you guys might know if you ever take physics or anything like that, that gravity is quadratic, right? Negative 9.8 meters per second squared. So gravity works in a quadratic manner. So when you throw a ball or jump out of a cannon or anything like that, gravity is quadratic. What happened when his parachute came out? Linear. It was a steady, didn't speed up, didn't slow down. It was just the same darn speed all the way down, right? And that's why it's kind of half quadratic, half linear. Okay, even if you're not done with that one, go ahead and go on to step 2. And then I want to get through 3, 4, 5, and 6. So see if you can get through them. So the bumper cars is trying to fool you. Don't be fooled. Pay attention to your labels and ask yourself, what is my independent variable? What is my dependent variable? On your guys' screen, does it specify that we're talking about the blue car? Or green car? Is it green? Because there's like 4 red cars too, right? Everybody's doing the blue-green car? Okay. Sometimes I don't know what it says on the student end. Yeah. Except it looks blue to me. Does it look blue or green to you guys? You guys are looking good. Is anybody on step 4 yet? I want to look at your screen so I can see what this person's... Maddie, you're on step 4. Can you go back to 4 so I can see it? Thank you. That's all I needed to see. On the screen, you can see the exact answer, which is laying right over top of what a lot of you did. That's what our bumper car should look like. Looks like some of you were trying to freehand it with your pencil, which is kind of hard to do, right? If you would have made a dot and used that tool that does the straight line, it's okay. Freehanding is, especially if you don't have a mouse, or if you have a Mac, then you can't do it with your finger either, right? Whereas, anybody use their finger on their screen? Did that work? I want to talk about, go ahead if you haven't done it already, go to step 4. And it says Jenny. Jenny doesn't know what the heck she's doing. I bet Jenny looks at this graph and says, hey, wait a second, fails the vertical line test, right? If you look at the dotted line. So Jenny would say, hey, that's not a function. What's the flaw in that logic?
Just going back in time.
Yeah. My independent variable is time, not horizontal distance from the left-hand side of the starting point. That's not what I'm doing, right? I'm not comparing horizontal distance versus vertical distance. I'm comparing time, okay? So if I get in my car and I drive down the road in a straight line for an hour, my odometer is just going to be a function of time, right? It's just going to keep going up. But what happens if I get in my car and I drive around the parking lot in circles for an hour? Is my odometer going to know the difference? It's still time and distance, right? It doesn't matter if I drove in circles or if I drove in a straight line. So do you see how that can be confusing, and it confused Jenny? She didn't understand what the actual independent variable was. So again, I want you to think precisely. We would say in this particular example, the distance driven is a function of time. The distance driven is a function of time. Distance is the dependent variable. Time is the independent variable. The distance depends on the time. The distance depends on the time. Okay. Ferris wheel. We got 6 minutes left. You should be able to finish the Ferris wheel. Some of you are looking good. I shouldn't show it. You guys are looking good on the Ferris wheel. Let's see. Once again, I'm going to come look at Sophia's graph because I can't see Sophia's graph. So I'm going to look at yours again, Maddie. Does it show me step 6? Yeah, okay, yep, that's all I wanted to see was Sophia's. Most of you are doing a very good job of recognizing that the height above the ground has more of that smooth curve to it. In fact, any of you who understand or have done anything with trigonometric functions, you would recognize that curve. What's it look like? We'll do this later in the semester. You guys ever seen the graph of sine or cosine? Just looks like a wave, like a radial wave, right? And that's what we're doing because it's a circular motion going in the circle. So if you want to see the exact answer, there it is. And you can see it's going over most of yours. I want you to finish this one, and then your assignment is going to be to do part 2. I want you to do part 2 before you come back to class on Monday. And before we run out of time, I want to show you one thing on part 2. You can click on it right now if you want. It's the second link on Blackboard. It says Function Carnival Part 2. It's the second link, and it's going to introduce you to Cannon Man again. It's going to say, hey, you just did Cannon Man. Oh, that's not what I wanted to do. Oh, yeah, okay. It's going to show you Cannon Man again. I want to go to step 8 because when I've done this before, people have gotten confused. Remember when I said there was 4 ways to represent a function? What were the 4? A verbal description, a chart or a table, a graph, and an equation, right? Well, these are giving you 3 out of the 4. They give you a verbal, they give you a graph, and they give you an equation or a value to punch in. It's actually like a tabled value where this is the input, this is the output. So I'm sorry, not the equation. It's giving you the table of values, just one value here, the graph, and the verbal description. Your goal on this step, which is step 8, is to match them up in groups of 3. So if this one goes with this one, goes with this one, I would put them together into a grouping of 3. Do you see how that works? That's what you're going to try to do. And there's only one way to do it, because one of these in one graph and one verbal description goes in a group of 3, so there's a right and a wrong answer for that one. Otherwise, you should just be able to go through and do what the directions tell you to do. And what I'm going to do then is I'm going to expect that you have this done by the time you come to class on Monday. And on Monday, we'll look at it really quick and we'll discuss any discrepancies or any misconceptions that anybody had. The other thing that you can start doing is working on your 1.1 quiz, because that's available. And you guys know I lecture you all the time. Don't fall behind and scramble to do them all at the last minute. So you can start working on that. Okay, that's all I got. Have a good weekend. See you Monday.